Okay, good morning, class. Good morning, class. Are you sad of the test you got? Yes. Which means to say you're still not prepared for the upcoming control test. Okay? That is still on chapter 1. We must still test you on exponents. Okay, but in tomorrow's lesson, we will look at how you should have answered those questions. Please re-answer the test 3 at the back of your maths books, okay? As part of the homework for tomorrow. The difference with answering it now compared to in the back of your book compared to have answered it now in the test setting is that now you can speak to somebody and you can reference to the sections in your notebook at least, okay? So let's just pull the calculator up here. Okay, so let's go. It was exercise 2.6, correct? In exercise 2.6, we'll just get there. Okay, you had to do the second column in 2.6 or the first column? Second column. Any issues in number 1? Any issues with the first column in number 1? The second column in number 2? J. Any other issues other than J? J. Any other issues? L. Anything else? Which page is this on? 50. Right, so those are the two numbers that you've highlighted. Look at the first one. Big J. So firstly we need to break products up, bases up into products of its prime factors. So 8 can be written as 2 cubed raised to the r plus 2 times 2 squared raised to the negative 3r over 2 to the negative 2r. So what do? When we're multiplying it, bases are the same, we add the exponents. If a base is raised to a higher exponent, we multiply the exponent. If we're dividing and bases are the same, we subtract the exponent. Okay, so let's do our thing here. So it's going to be 2 to the r times 2 to the 3r plus 6 times 2 to the negative 6r all over 2 to the negative 2r. That's all. Now what? When we're multiplying and bases are the same, what do you do with the exponents? You add. So it's r plus 3r plus 6 minus 6r minus 2r, which become plus 2r. You all okay with that? And that is equal to 2. We add the like terms. R plus 3r is 4r minus 6r negative 2r plus 2r is 0. So they cancel. If you 2 to the 6 and 2 to the 6 is 64. And not 32. 2 to the 5 is 32. Right? Who asked this question? Where did you go wrong, Michael?
So is there saying 2 squared?
At this point here. So you got 2 squared there and 2 squared here. How can you have 2 squared and 4? Okay. Any other problems? So anybody else that got this one wrong? No? You don't want to share? Mustn't be like it. Right, L. People, 1 over x to the minus 1 can be written as 1 over x plus 1 over y over. Now x to the negative 1y, that's over 1. So where must this negative 1 go? To the denominator. So it's y over x. Minus x over You all okay with that? What's my LCM in the numerator? What's the LCM? XY. Not so. So I'll multiply that by y. So I'll get y, multiply that by x. And it must be divided by. So this line here is divided by, what's my LCM in the denominator? Also xy. So that must be multiplied by y. So it's going to be y squared. This must be multiplied by x. So it's minus x squared. People, what's happening here? Difference between two squares. So it's y plus x over xy times xy over difference of two squares, which is y minus x into y plus x. Okay, now what? Cancel. Y plus x cancel. xy cancel. So what are we left with? 1 over y minus x. Okay. Any confusion there? No? Who asked this question? Where did you go wrong, Michael? Didn't factorize. So you landed off with y plus x over, sorry, not there. So you landed off there with that being y squared minus x squared. Is that what you have? Okay. So you must always factorize. So you can cancel the factors out. Anybody else? Nobody else did the homework, that's a problem. Am I right with darling? Oh, you copied it. Okay? I'm joking. Ik jok maar, man. Right. Then we went on to exercise exponential equations. Not so. Then you had to do the first column in exercise 2.7. You all agree with that? Any problems with number 1? Number 2? Sorry? What? M, 2M. M and D. No? B. V. Give me a chance. I can't even remember. Alright, let's go again. I had 2D, no? 2D. B. V. No, but there was a letter prior to this. M, okay. I just said now, you can't give me all. What's wrong with you? So it's exercise 2.7. I'm not so young like you that can remember everything, man. Exercise 2.7? Page 53. You see, I don't even remember the pages. Number 2. You see, if I start memorizing your names and I start memorizing the page, then I start forgetting the formulas. So I can't at no expense do that. Okay. Wat gaan nie in? Computer got time to play games this morning. Right. So it's going to be V. What's the other one? M. What's the other one? P. What's the other one? What? S. All right. Let's start with V. Don't have to do it in alphabetical order. Right, who asked for V? Right, go for it. What did you do? You mustn't say rather, right? I wrote. Okay, I wrote, yes. Free. Yes. Correct. 3 to the power year. your
3, 8x minus plus 4.
Since bases are the same, exponents are equal. So what do you do from here?
That's where I start.
But is both bases not 3? Right? So I say therefore. Okay, she stopped here. As you can see, the bases are the same, so exponents are equal. So you got 3x minus 6 equals 8x plus 4. X is one side, numbers the other side. So 4 plus 6 is 10. 3x minus 8x is negative 5x. Divide by negative 5 both sides. So x equal to negative. Okay, you got it? Right? Look at P. Who asked for P? Right, go for it. You are out, yes? You are a yes.
3x times 3 times e to the power of 8 equals minus 8.
Huh? You see, you don't listen when I speak. No? I said, don't break this up. You remember I said? You remember? You're still doing your own thing. I said, Robert, keep this, because you were the one that was breaking this up, as you just did now. And then you would have said 3 to the 3x times 3 to the minus 6 and you divide. Don't do that. Okay. You're making life difficult for yourself. You bring that up there, this now becomes 3 to the x minus 2 is equal to 3 to the negative. What can we say from here? Therefore, x minus 2 is equal to negative. When bases are the same, exponents are equal. X is one side, numbers the other side. So it's going to be x plus x is equal to 2. What's x plus x? 2x. Divided by 2 both sides. So x equal to? Alright. Anybody else got this question wrong? Yes, Michael, where do you go wrong?
I took the x on that side over.
So you went the other way around. So you said, you kept minus 2 there, so minus x, you kept, the x is going that side, no? Minus it. So you got minus 2x is equal to minus 2x is equal to negative 2. Is that what you have?
No, I wrote x minus 2 minus x.
X minus 2 minus x. We also got that. And then what did you write?
That's when I saw.
Don't just stop and think you're wrong. Just carry on. And we'll see where you went wrong. Because why? That is the absolutely correct step that you did there. From here, it's a matter of solving the equation. Okay. Yes? On at M. So you don't need M. Okay, nice. Where did you go wrong?
I didn't bring up the 25.
Okay. S? Who asked S? Sorry? No? Anything to the power 0 is? Anything to the power 0 is? 1. So you're going to write 1 as 10 to the 0. Why? Because I want the bases the same. Why? So that the exponents can be equal. So x equal to 0. You understand? Is that your mistake? Okay. Anything else? Right. For homework, I would like you guys to do exercise 2.7, second and third column. So you try number 3 as well. Okay? What I do is I'm going to copy this here. There's a second column, inclusive of number 3. Okay. Alright. Next heading, solving exponential equations using trial and error method. I think this is the last exercise in this, the last exercise in this chapter. At this point, you can start answering, check your skills. Okay? I would like this assignment on Thursday. No? Is that okay? But this exercise not that long. Okay? But at this point, as I told you and reminded you before, is that at the beginning of the lesson, I told you already, you can start answering, check your skills. Not so. Because you could have answered in number 1, A, B, and all of those things. You could have answered many of these questions after the third or fourth exercise already, or lesson on this. Okay. So as we did before, you mark it, and we'll discuss where you went wrong. Okay, we'll first record who did their work, and then we'll take it from there. Okay. So we said we're going to look at solving exponential equations using trial and error method. Okay, there's 2 ways to do it. I'll show you tomorrow a quicker way, but it's done in grade 12. Okay. It's called using logs. Okay, but for now it's just going to play around with values, and you can see how the relationship exists between that. Okay, so let's see what they say here. Which page is this on? Sorry? 54. Page 54. Okay, page 54. We cannot always express all exponential equations as a power of equal bases. So what we've done thus far, we've dealt with equations where we could have equated or made the bases the same so that the exponents can be equal. Okay, where we could have equated the exponents. But here they are telling us that it's not always the case where we can equate the bases. Okay. To find approximate solutions to the equations, we use a method called trial and error. Trial and error. Okay. You try something and it doesn't work, you try again. Until it doesn't work, and you try again and try until you get an answer. That is basically trial and error. Okay. Then we are told to find the approximate solution to the equation by trial and error. We use a procedure known mathematically as bisection. Okay. So we're looking at the example on page 54. The question says solve for x correct to 2 decimal places. So right there, solve for x correct to 2 decimal places. Okay, so looking at 3 to the x is equal to 18. You can stay here if you want, otherwise you can. Okay, so solve x correct to 2 decimal places if 3 to x equal to 18. So before, if it was 3 to the 81, 3 to x equal to 81, that is simple. That's 3 to 4. So x is equal to 4. Not so. Why? Because the bases could be equated or written as the same base. However, we can't write 18 as a base of 3 only. Not so. So we know 18, if you break that up, it's going to be 3 times 3 times 2, which is 3 squared times 2. So if that is equal to 3 to the x, we can never say that x is equal to 2. Because 3 squared is 9. Not so? That's not going to work. So what we do is, we see, okay, between which numbers does 3 to the x lie? We know that 3 to the 1 is 3, 3 to the 2 is 9, which is still less than 18, 3 to the 3 is 27, which is more than 18. Not so? So now we know that 3 to the x has to lie between 3 to the 2 and 3 to the 3. Not so? 3 squared and 3 cubed. So that x has to now be equal to, x has to be equal to 3, 2, comma something. It can't be over 3 and it can't be under 2. So it has to be between the 2. Not so? So it must be 2 comma something. So we can start anyway. We're going to start at 2.1, 2.9, 2.8, whatever. But we start, let's go in the middle, 2.5. Then we know we must go up or down. Not so? So let's go. On our calculators, we say 3 to the exponent, 2 comma. And we say we're going to go with 5. So, is it 2,26 or 2 or less? Less. Not so. So let's then go less, 2,24. That is also over. So it must go less or more. How can it be more? Sorry? Oh, sorry. Jesus. What number am I thinking? Right, I'm supposed to actually go up. What's wrong with me? Many things. Right, so which means to say I must still go up. Okay. If you go up, it might be over. So let's stick with 6. Okay. Now, it's fairly close. Not so. So let's go with, we add another digit. Let's go with 5 in the middle. That is over. Can you see that? Let's just keep it just under. So that we change to a, so it must be less, 4. It's still over, 3. There we go. Can you see that, people? So that is 17,9. It's very close to 18. 2,6, 4 was over 18. Not so. Let's choose another number. Go with another 5. You see 18,08. You see that? Let's go with 4. Let's go with 3. Let's go with 2. Let's go with 1. Wow. Nice. So what's the number? So 2, 6, 3. You guys understand? So remember I said 2 decimal places. So that's not actually, this is 3 to the x. So therefore x is equal to 2, 6. This is the process of trial and error. You guys understand? We'll do another one. Let's go straight into exercise 2.8. Exercise 2.8 on page 54. Let's do A. Right. We're going to do number 1A. So you got 5 to the x equal to 1. Let's do this one together. Okay? You say 5 squared is 100. Is that what you say? What are you saying about 5 squared? 5 squared is 25. 5 cubed? 125. Which means to say 5 to the x lies between 5 squared and 1. So this has to be 5 to the exponent 2 comma something. So I'm going to give you a chance to work out the value for which this should be. Don't understand, you bring your book to me and I'll try and explain. Okay. So what did you guys get? 2 comma 8? 6. 862. Now let's check. So it's 5 to the exponent 2 comma 862. Sure. You got 861? It's just under. Not so? Now what other one is? Just over. So in both cases, so therefore 5 to the x is equal to 5 the exponent 2 comma 86. So therefore x is equal to 2 comma 86. You guys understand? Sorry? Disappeared. Why? Because as I said here, oh, 1 decimal. So that's supposed to be. Remember, if the instruction is 1 decimal, you must give 1 decimal. The example was 2 decimals, so I expected them to give 2 decimals. So the answer actually is 2.9. 2.9. But the more decimals we use, the more accurate the answer would be. Not so. So if I put in the calculator 5 to the exponent 2.9, see that's 106. Okay, which is just over. So I think we would have, the 8 would have been a better. That's also way under. Okay, but like I say, if it was 2 decimals, it was closer. 3 decimals would even take it closer. 4 decimals, like if you had gone and said 8, 6, 1, 1. Can you see that? 1, 8. You see it is over. So we try just keeping it under. 4. You see that? Let's go with 3. Okay, let's go with the 5. Let's go with 6. Can you see? 5, 5. Can you see that, people? 5, 4, 5. Can you see? The more decimals I apply, the closer and closer to 100 I will get. You guys understand? And that is how it is. Okay, we'll do another one. Right, let's do D. I don't know if you guys are ready for D. Huh? This is 3 times 7 to the x equal to. Okay, let's first try the C. Okay. Let's first try the C, and then we will do D. Okay. I'll give you again a minute to sort your lives out. You will go to that point, it has to be between 2 to the 4 and 2 to the 5. You all agree with that? So what do we say now? So it will be 2 to the exponent, 4 point something. So we go again, 2 to the exponent, 4.5. I go in the middle. Okay? 2 to the exponent, 4.5. 22. So that is, what are we looking at? 20, 30. So I must go up, not so. So we go 8, 9. So it's just under. What's the number 13, eh? So let's go with another 5. So it's over, ne? So what do? Just minimize it. So it's 4. Still over. 3, Not 2 but 1 you say? So that is also over. So if you really wanted to keep it under, you know, let's say 0, 5. This is under. 0, 9. Still over. 8. 7. Can you see it's on 36. Just under. Can you see that? So if it was to 3 decimal places, I would have written 2,907. But what did I say? 1 decimal place. So I'm just going to say comma 907. So that is 2 to the x is equal to that. So therefore, x is equal to 4,907, which is 4, you guys understand? So as promised, let's look at D. 3 times 7 to the x equals 22. So normally what we do is we want the base with the variable exponent standing on itself. Okay? So what do I do first? Divide by 3. So we've got 7 to the x is equal to 22 divided by 3. So I'm going to work with decimals. 22 divided by 3. It's going to give you 7, 3 recurring. So I got 7, 3 recurring. Okay. But 7 to the 1 is 7. 7 to the 2 is 49. So what does that mean to say? That 7 to the x definitely lies between 7 to the 1 and 7 squared. Not so? So what can I say? So that's going to have to be 7 to the exponent 1 point something. Not so? So that would be 7 to the exponent 1.5. What is the number we're looking at? 7, 3 recurring. So that's way over. Not so. So let's go with 1.1. That's also over. So that means to say I must put a 0, 5. Still over. 0, 3. 2. There we go. Can you see that, people? So it's just under, so I could have put a 5 there. 4. That's still over 4. I'm just trying to keep it under. Wait, what am I doing now? Change that to a 4. To a 3. Can you see it's just under? You guys understand? So it's here, 7,3 recurring is 7,3333333. Okay. So that means to say that this is going to be 1,023. But if they wanted to 1 decimal place, so therefore x is equal to approximately 1. You guys understand? So if it was 2 decimal places, it's 1,03. 3 decimal places, 1,023. Okay. And that's that. People, for homework is the remaining sums of this exercise, which is exercise 2.8. Don't forget, you check your skills for Thursday. That answers we'll do. The answers to these questions we'll do in tomorrow's lesson, which will form part of Numbers, the new chapter. Okay. People, enjoy the rest of your day. Good morning, class.